Hello, my name is Jennifer Winkleman, and I'm going to be doing this Math 111 Intermediate Algebra Test 1 review. I have a lot of problems on this review, much more than your teacher is going to have on the test, and I believe that my problems are quite a bit harder than what your teacher will have. So if you can bear with me through this review, you should be fine on your exam coming up. The one thing I will mention is that you want to make sure you have a scientific calculator, not your phone, the ones that you can buy at Walmart for about $14 or less. That way, if you need to check your work, it's very easy for you to do it in there, and also to make sure that you can be able to do simple computation so that you don't get something wrong on the test that otherwise is not that bad of a problem if you're not so great with adding, subtracting, multiplying, negative numbers, those kind of things in your head. So without further ado, let's go ahead and get started, and I'm going to go through and go over these problems, and you can follow with me, okay? Let's look at this very first one. It says find the real numbers that satisfy this equation. This is an absolute value equation. In absolute value equations, the number, the 5/8, represents distance. So because that represents distance, the problem is that we can look at distance also on a number line. And because of this, our answer could have a negative x or positive x. So if you look at this on a number line, you have two possibilities. X is equal to a positive 5/8, and it's also equal to a negative 5/8. Now, with absolute value, if you have a problem similar to this, you're always going to get one answer that's positive and one answer that's negative. Didn't see any other problems in this section that have further things with absolute value, which you'll see later in that class, than where you have other possibilities. I want to show you an example of a trick question that you'll see on your test. At the beginning they say, write no solution if no solution exists. Well, if you have a problem that looks like this, if it starts out with negative 5/8 is equal to x inside those absolute value brackets, that is an example of a no solution type problem, and you want to write that out. The reason why is because I told you the number 5/8 represents distance on a number line. And although the numbers can be negative, the distance, whenever you measure something in those real life units, they can never be negative. So in this case, if it starts out like this as a negative, you know it is a no solution. In our previous one that we just did not start out as a negative, so it was okay. Now I'm going to go on to the next slide where I'm going to talk about some definitions and some properties that you'll need to know for the test. So let's go ahead and do that. Okay. Now for each of these, for the commutative and associative properties, you have one of addition and one of multiplication. So I'm going to give you some tips on how to recognize them. As far as I know, I'm just going to write this for commutative, okay? Is that you have one for plus and one for multiplication. Now, on your test, from what I can tell, is that your teacher is going to give you an example of what it would look like and want you to write down which one of these properties it is. So, how to help you remember what the commutative property is, I'm going to tell you, you move the numbers. Now, x can be a number. I'm going to use the pound sign for numbers, okay? So, you physically move the numbers. So, if I have 4 plus x is equal to x plus 4, I switch the positions of x and 4. So because I did that, I moved them. That is a commutative property. If you ever heard someone say I commute to work, that means they're moving, they're going to work. That's an easy way to help you remember commutative. If I did multiplication, like 3 times 7, that would be equal to 7 times 3. These are examples of the commutative property, okay? Moving the numbers. Doesn't matter how many there are. In most examples, there's only 2 numbers, though. That's what I've kind of noticed. So if you have 3, that doesn't mean it's not commutative, but you have to watch the numbers and see if they actually move. Now let's look at the associative. All right, I'm going to write this for associative, okay? And there's also the plus and the minus. Now, with associative, there's a couple things you need to realize. You're going to have parentheses, you know, those things inside those little kind of not really brackets, but parentheses, okay? And it's the parentheses that moves, not the numbers. Not the numbers. They don't move, okay? We'll see that. Another thing is, in most cases with the associative property, you have 3 things. I don't want to put numbers. Let's just say things. So let me give you an example of what this would look like. If you had 2 plus 3 plus x is equal to 2 plus 3 plus x, notice, did my numbers move at all? No. But watch what's going to move. Take my parentheses right there in the first one, and I move it to that one. So the parentheses moved. That's the associative property. Let's look at one for multiplication. If you had, and I did an x there so I could do like 7 times 8 times 11 is equal to 7 times 8 times 11. And watch this parentheses goes from here to there. That's the associative property, okay? Now, going off of this, let's look at the distributive property. That one usually involves having you example of something that's been multiplied out. So I'm going to scroll on down. So let's look at distributive property. So if you ever heard, distributing something, if you had like 2 times x minus 3, what they'll show you is equals to 2x minus 6. What did I do? I put that 2 in, and I multiplied by the x, and then I multiplied by the 3, and my 2 in my parentheses went away, and I got this brand new problem over here. Brand new answer, sorry. So this is an example of what the distributive property would look like. They've done this math. Now, the next one on the list, let me scroll back up, was the inverse properties, okay? There's two inverses. There's the additive inverse and the multiplicative inverse. So inverse, we got a plus and a multiply. Here's an easy way to think about inverse. Opposite. What is the opposite, okay? What is the opposite here? So if I'm looking at addition, if I have 1, and it's addition, so there's my plus, what's the opposite of 1? Negative 1, right? Negative 1. This is the inverse part, the thing I just underlined. And this is equal to 0. 0 on that side is important, okay? That's what makes this an inverse, the opposite. Now, let's look at the multiplicative one, okay? With multiplicative inverse, all right, it's a little different. It's not going to be equal to 0. In this case, if I have something like 2, what's the opposite? You might have heard people say the flip, the opposite. It's the reciprocal. You might have heard that word. So the reciprocal of 2, multiply that out, is 1 over 2, where you take 2 over 1 and you flip it, okay? This is equal to 1. So with the multiplicative inverse, it should be equal to 1. And with the additive inverse, it should be equal to 0. And we'll see why the 0 and 1 is important in the next property, the identity property. That's where I think they get these from. So to give you an idea of some more reciprocals here, so like if you had 1/4 times 4 over 1, right? Even if I had x times 1 over x, those are the reciprocals. In both cases, when I multiply them out, they all equal 1, okay? So that's an example of the inverse, the opposite. Now, last but not least, I have the identity properties. So let's scroll down. The identities. And I'm actually going to leave some room up here because we need to look at this to get an idea of what I'm talking about. About right there. So we have identities for the multiplication and addition. Sorry, I kind of said that backwards. Now, when it comes to identity, I want you to think in your mind identical twins, because that's what we're going to be looking for, okay? Identical twins. So I talked about that 0 being important. Well, I want to get an identical twin. So if I have 3 plus something equals 3, see? Those are my twins. The same thing. What goes in that blank? What number plus any number is always going to give you the same number? Well, that is 0. Now, do you maybe see that connection, how these two kind of play with each other? They're kind of related. That's what I'm looking for, those identical twins. That's the additive identity. Now, the multiplicative identity, it's set up similar. So if I had, let's see, 4 times some number will give me 4. Again, those are my twins. Notice, I'm looking for my twins. What number is that? 1. 1 times anything is always that number. And notice, I'm going to use the blue. What was that one? 1. So these two properties kind of play off of each other. They're kind of related in the fact that if you can remember one, you can remember the other one. Just remember inverse is opposite, and identity, you're looking for the twins, okay? It's going to have to give you the same number. All right, so just use that to help you figure these out. So I'm going to stop here before I move on to the next problem. So we take a break. When we come back, there's a lot of definitions thrown at you, but make sure you know how to identify these. If I gave you those examples, you could tell me which property it's related to. Okay? All right.